Hey, what's up, guys? Welcome to KG Education YouTube channel. Today, we are going to find out the secret behind on converting RGB image into grayscale image. So, today, our task is to convert the RGB image into grayscale image without using the built-in functions. So, if we go into the theoretical aspects of a color image, actually, a color image or an RGB image is composed of three layers, which are the content components, contributions from red color, contributions from green color, and contributions from blue color. So all these three comes together and stack as the layers on top of each other will create the entire color image. So today, our task is to identify the relationship and these contributions of each of these layers and convert the color image into a grayscale image. As I mentioned earlier, the RGB image or color image composed of three layers, red, green, and blue. So each layer intensity values varies from 0 to 255. So similarly, a grayscale image also has the same intensity values. However, since our task is to convert these three-layer contributions into a single layer to obtain the grayscale image. Therefore, we have to identify the relationship or the contributions of each layer of RGB layers to obtain the grayscale image. So therefore, there is an equation to obtain the grayscale image intensity values with respect to the RGB layers. So here we have mentioned the grayscale image intensity value is equals to 0.2989 into the R layer or red layer contribution plus 0.5870 into G, or in other words, green layer contribution plus 0.1140 into B, in other words, the blue layer contribution. So this will calculate the expected intensity value of the grayscale image for a particular pixel point. So with that, we can or obtain a single layer of intensity values which is equivalent to the grayscale image intensity values. Let's look at the coding part of the conversion of RGB image into grayscale image without using the built-in function. As customary, I will type close all and clear all commands. So the first of all, I have to import my image into or load my image into color image into the workspace. So I will use a variable and I use read, and within brackets I will input my name. So here I have my name in the PNG format. So once I load it, I can use the show command and confirm that I have loaded the correct image and it is good to go for the second step of this grayscale conversion. Right, so I got the image correctly. Now the next step I need is to split the RGB components. So I am going to split the red, green, and blue color layers. So if we go to the workspace in here, the workspace variable composed of the number of rows and number of columns, and it is multiplied by 3. So 3 means the number of layers that the color image compose, which is we use as the RGB or red, green, blue. So I'm going to split up the these values. So I will create the variable capital R. So my image is capital I, the color image. Now I have to split the first layer. So I need all the rows, all the columns, and only I require the first layer. So this gives the red color layer intensity values only. So I can get red color layer intensity. Similarly, now I'm going to copy this command twice to get the blue, green color and the blue color. So I'm here, change the green. Now I require the second layer for the access the green color. So I will like this. And the final layer, the third layer, which gives me the blue color layer. So once I run it, I should be able to get 3 additional layers variables in my workspace. So each component has the same rows, number of rows and number of columns. Now I'm going to extract number of rows and number of columns in color image that I have uploaded to MATLAB. So simply I can write this using the size command. So I'm inputting my color image variable capital I, and first dimension I'm going to access, which gives the rows. And similarly, I can copy this to here, and I will copy this same thing here, and using the same, now I'm accessing the second dimension to get the number of columns, right? So similarly, I will create new matrix to save the grayscale intensity values. So this matrix will give me the grayscale image. So I will type I gray. So since I am creating a new empty matrix, I will use the zeros command. Now I'm going to input my dimensions, simple R and simple C, which are my dimensions. And also, since it is a image that I need to display at the end, I will use U-int8 format to get the final values. Right. Okay. Now the next step is to create the nested for loop, nested for loop to access each pixel point of the image. Right. So I will create the nested for loop. First access the rows, and second for loop will access the columns. Right. So now I have created my nested for loop. Now inside here, I am going to type the equation that I have shown you earlier, previous case. So where the mathematical part, the equation part comes into the. So my output should be I gray, I comma j. I'm storing whatever the calculated intensity value in the respective pixel. So then the first value, have a look at my let's go to the value. So first value is 0.289. Okay, so I will type 0.289. Yeah, 2989 should be 2989 multiplied by, so should be multiplied by the respective red layer pixel point. So I can write R J, and I will add the plus point and go back to the second value is 0.5870 multiplied by the green layer respective pixel point icon j, plus again I go back to the blue layer, the coefficient is 0.1140, type here 0.1140 into the blue layer respective pixel. So this will give me the intensity values calculated, multiplied, and stored in this newly created empty matrix. So once I run it, see, right. So I have obtained the results here. So nested follow piece works fine, and I will use now show the grayscale image. So I will use the figure command, and I will use ImShow, and inside that I will input my newly created matrix variable on site. Let's run it and see how it is looks like. Right here, I got the results. So this is my color image in my left hand side, and this is what I have obtained in my right hand side as grayscale image. So simply using that equation that we discussed, so we can convert whatever the color image without using a built-in command and with corresponding to the RGB color layers and convert and obtain the respective intensity values of the grayscale. So that's it from this video. Thanks for watching and see you on next episode.